So for the equilibrium experiment today, we're looking at factors which can affect the position of equilibrium, and Le Chatelier's principle tells us that the system will always try and respond to minimise the change on the system. And we've seen several different ways that this system can be affected. We've talked about adding chemicals. Chemicals being added will increase concentrations. And when concentrations increase, we have more collisions and the rate of the reaction is increased. But your job is to figure out which reaction is being affected. There are two competing reactions, a forward and a back reaction. Also, when chemicals are removed, the removal of chemicals decreases the concentration. Now that decrease in concentration could be from a secondary reaction, which uses up the chemical and prevents it from being used in the equilibrium system. The reaction between acid and sodium hydroxide is a good example. So when it's used up, we reduce its concentration and the number of collisions for the reaction decreases and the rate of the reaction goes down. So its competing reaction is actually winning the race and will be favoured and move the position of equilibrium. The first reaction today is between iron nitrate in the forward reaction and the iron thiocyanate complex, which is involved in the back reaction. So the more iron thiocyanate that's produced by the forward reaction, the more red the solution becomes. Stronger red colour means that the forward reaction is being favoured. Now the iron nitrate, which is a product of the back reaction and is yellow in colour, as the solution becomes more yellow, it means that the back reaction is being favoured and the position of equilibrium is moving to the left. Your second reaction today is between chromate and dichromate ions. Now for this one, the colour changes are a little bit on the subtle side. The two complexes are relatively orange-like in colour, and one is just slightly stronger or more orange in colour than the other. So when you perform the experiment and you make your additions, if you don't initially see any colour change, then add more of the chromate or the dichromate, maybe 3 or 4 times more, to accentuate that colour change. The third reaction today is between the cobalt hexahydrate, which drives a forward reaction, to produce the cobalt tetrachloride, which is blue in colour. So as the position of equilibrium favours the right because of a stronger forward reaction, the solution is going to become more blue. And the back reaction, which takes the cobalt tetrachloride and turns it into cobalt hexahydrate, which is pink in colour, as the back reaction becomes favoured, the solution becomes either less blue or more pink. So a shift to the left, the colour should become more pink. A shift to the right with a forward reaction, the colour should become more blue. And you're going to be able to tell which reaction is being favoured by those colour changes. So as you change the temperature by putting the test tube in a beaker of warm water or cold water, it's going to tell you whether each reaction is an endothermic reaction or an exothermic reaction. Now remember that the endothermic reaction will be favoured when the temperature rises, and the exothermic reaction will be favoured when the temperature drops. For the last reaction today, we're looking at ammonium chloride as it dissolves into water. So the forward reaction is when the ammonium chloride dissolves to form a solution. So a disappearing precipitate is a sign of the forward reaction being favoured. Meanwhile, if a precipitate starts to form, it means that the back reaction is being favoured as ammonium ions and chloride ions combine together and reform the insoluble ammonium chloride. Now, to start the experiment, you're going to have to get your solution saturated. Get it saturated with ammonium chloride. So over the bench, you're going to keep adding ammonium chloride until no more can dissolve. So you're going to use the device on the front bench to dissolve the ammonium chloride more quickly. Carefully place the test tube into the rubber holder on the top, and with some light pressure on the top of the test tube, push down and allow that vortex motion to dissolve the ammonium chloride. Keep it pressed down and mixing for about 20 seconds at a time. Look at your sample and ask yourself, has the ammonium chloride dissolved? If it has, then you have to keep adding more, vortex it for some more time, and you'll keep adding ammonium chloride and then vortexing. Keep doing this until the ammonium chloride will no longer dissolve. Getting that initial crop of ammonium chloride to dissolve does not mean that your solution is saturated. It's not saturated until it can no longer dissolve any more ammonium chloride. So keep those additions going. It's vital, otherwise the last experiment will not work. A small amount of solid still there. Is that clear?
Yeah, I think so.
Make sure she gets the content.
Yeah, see, all I, you know,
Okay.
all I see is 6M up here.
Now go out to what you're doing.
There's a 6M HCl.
I know, that's
Dr. Elliott?
Solid. Still in there.
Okay.
I did.
We need it again.
This is the 6M
Solution.
That's
It's
6
saturated.
Okay.
Yeah,
Well, how about we add
that was the
another?
only one I found.
We add another one in here, that one 12 in HCl.
No, doesn't quite work. That doesn't work.